designing, manufacturing, installing, and maintaining the high-speed electronic computer, the largest and most complex computers ever built.
Hello, everybody. Welcome to another episode of the Building Better Systems podcast, where we explore tools and approaches that make us more effective engineers and make our software safe and reliable. My name is Spat Morina.
And I'm Joey Dodds.
And today we're joined by Stephen Magill and Tom DuBuisson. Stephen and Tom are co-founders of MuseDev. MuseDev is actually a Galois spinout. It's a software company that aims to bring analysis tools that help developers quickly find and fix bugs. And we're going to get into what that means kind of later on. But Stephen and Tom, thanks for joining us.
Thank you. Glad to be here.
We're happy to have you. You just recently launched, so you're probably doing a lot of these interviews and things like that. Or is this kind of a new for you?
Yeah, it's an exciting time for sure. Yeah, we're out there on the GitHub Marketplace now, and so yeah, we've been talking to some reporters, putting some blog posts out there, just describing the system and the capabilities, and making people aware that it's available. So yeah, very very excited.
Fantastic. We start kind of with the same, pretty much the same question with everybody. So, what is your approach to building better systems? Tom, you want to start with that?
Absolutely. Choosing a good foundation and good people. That's the very, very start. After foundation people, then you can start talking about quality processes like code review. But it all starts with a basis. I'm not ever going to start a financial company writing assembly with the wrong people.
Yeah, I agree. I mean, it's often, I think when it comes to quality systems, and by that I mean like systems that are reliable, that are secure, that perform well, it starts with cultural practices and getting people in the right roles, but getting people sort of focused on the right things as well. And so, you hear a lot about like DevSecOps as a new approach to security, and really all that is just having developers focused on security, making security a core concern throughout the process, not just at the end of the process when the software is delivered, right? And so, those practices that support that, things like code review, things like developer training, end up being hugely important.
And this is something, I guess, with the company that you two have started, it's not something you need to be aware of just for yourselves, but that you're actually enabling others to be more effective at?
Yeah, that's right. So, like I said, the process is in place in the culture. That's where it all starts. But then there are certainly ways that tools can support that process, and that tools can help identify things. People are good at finding certain types of errors. Tools are good at finding certain other types of errors. And so you want to leverage each for what it's best suited to. And so I think the key thing with tools is when you bring them in, you want to bring them in a way that works with your process, right? You don't want to set up this agile DevOps forward process where you're pushing code immediately to production after each code change, and then bring in tools in a way that slows that down, right? You put that in place for a reason. Speed is a competitive advantage nowadays, and so you want to be able to bring in tools in a way that works with that process. And so that's really been our key focus as we build MuseDev, this company that's supporting this platform, Muse, that incorporates a bunch of static analysis tools. We're always thinking about how can we do that in a way that works with developers.
So actually, for the people who might not know what MuseDev does, could you give us a little bit of a primer on what you started Muse to do and what you're currently doing?
Sure, yeah. So we started Muse for a variety of reasons. One thing we wanted to do was make it really easy for people to make use of and try out static analysis tools. So, we've been all doing work in program analysis, static analysis, the founding team for a while. I started working in that space 15 plus years ago when I was doing my PhD at Carnegie Mellon, and then continued doing that sort of work for quite a while. But got more and more interested in how to get these tools in front of developers, how to have an impact on day-to-day development processes. Because often, cool research happens and it stays in the lab, right? You get these tools that work really well, but are kind of fiddly and require a lot of expertise to deploy. And so we really wanted to bridge that gap and make those tools much more accessible. And so the way we've done that is we integrate with GitHub. So we're available in the GitHub marketplace. It's a GitHub package as a GitHub app, just sort of single click install process, like all GitHub apps, to enable it on your repositories. And then you get access to a broad suite of static analysis tools. And we worked really hard to make it automated, make all the setup and configuration an automated process, so that in most cases you can just turn it on, it'll analyze your code and give you results. And then once it's enabled, there's been a focus on how do you most effectively deliver results to developers, because people don't want to go look at a list of 1,000 bugs that are sitting in the repository right now and start working that down, right? That is a way to do things. That's a way that some companies do things, but it's never very successful and doesn't bring people joy.
What works?
Yeah, so what's much more effective, and I think it's really Google and Facebook that first discovered this. They were experimented with a lot of ways of deploying these sorts of tools within their development processes, and published a lot on what they tried, what worked, what didn't. And what they really found to be effective was integrating into code review, right? It's this step, like we were saying earlier, it all starts with people and processes and workflows, right? And code review is like the key step that you can introduce into your development process to really increase the quality of the software you're delivering, right? It's a place where everyone comes together, that the team looks at the code, your peers examine the code change you made, offer feedback and comments, and everyone agrees on what changes should happen before it gets merged. So it's also a perfect place to surface the results of static analysis tools, right? If a tool finds a bug in the code change that you just wrote, it's a great time to mention that bug report, because the developer just wrote the code, it's all fresh in their mind. You don't have to do any work to remember what you were doing and think about how to fix that, right? It's the same sort of process that you'd use to respond to your peers' feedback during code review. And so that's really a key stage that we focus on.
So mechanically, this is actually something where the tool is finding bugs on cloud infrastructure, basically. The tool is running on cloud infrastructure to find bugs in your code, and then interacting with it feels like interacting with a code review. Is that what you're saying?
That's right. And it's amazing that it took us so long to get to this point as an industry. You would think that when we're reviewing code, when we're talking about the quality of the code, the bugs that might exist, of course, an automated process and a human telling you the bug might exist should be treated similarly. But no, it's taken us a long time to evolve to this point. And some of that's just technological barriers, and some of it's people's concepts about how to use a system.
So maybe this is too tricky of a question, but how should I think? Obviously, I think the very best time to get feedback is the second you save your code, or like the second you type in. How do I think about analyses that belong in that setting versus analyses that belong in the setting that you all are providing?
Yeah. So what delivering results at code review time lets you do is perform a deeper analysis of the code, right? So you have a longer window in which to work, in which to analyze the code. We shoot for 20-minute turnaround time on most projects, and so that really gives you enough time to do deeper analyses that catch things like thread safety errors, synchronization problems in multi-threaded Java code, null pointer dereferences that span compilation units, span libraries. And so, I think it's a great time to surface those sorts of results. The IDE is a great time to surface things that are more local and syntactic, right? So like, obviously syntax errors and so forth that would be caught by the compiler. Basically things that can be caught by the compiler can often be shifted into the IDE itself.
When you were describing Muse to us, you spoke about, this drive to not let cool research sit on a shelf, but making it actually accessible for people so that they get benefit out of that when it comes to finding all sorts of bugs and reliability, security. What did you identify as some of the important things to kind of lift from cool research space into usability? What are you excited about when it comes to what Muse brings to folks who might use it?
Yeah, so the race detection that I mentioned is a great example of cool research technology that's really at the cutting edge in terms of what program analysis tools can find. Tom mentioned, sort of in why haven't we been at this point before? Some of the technological barriers to getting to this point. One of those is just the sheer scalability of deep program analysis. So a lot of the tools that you see out there, Fortify and Checkmarks and these sorts of systems, they do a deep analysis of the code, but it takes a long time. And often people deploy these in sort of overnight runs that they run, maybe every evening or once a week or something. And really that's sort of the way that program analysis worked 5 or 10 years ago. It's only more recently that there's been a lot of work in extremely scalable analysis technology that lets you analyze millions of lines of code and still turn around an answer in 20 minutes. And so the thread safety analysis I mentioned and the null pointer analysis, there's sort of various really high-powered, from a mathematical perspective, analyses techniques underlying these tools. And so what we're trying to do is make those more accessible, so you don't have to understand the deep math. It's there. There's great research papers that describe how it works. But you shouldn't have to be a program analysis expert to use the tools, right? The point of the tool is to package all that up in a way that just delivers results.
Right. And so if I was a developer that wanted to use Muse after hearing this, what would be the sort of things that maybe I'm not even aware that I should be worried about, that I don't have to be worried about later, that wouldn't be easily accessible in other things?
Yeah, I mean, I think one thing that tools do a really good job of is catching all the corner cases that may not be top of mind. Maybe you read about it 6 months ago, but forgot, or that language feature has been deprecated and there's something else that's recommended now. All of these sort of quirks of various APIs and frameworks or language features, those are really hard to keep in your head as a developer when you're writing the code, and then as a code reviewer when you're reviewing someone's code. To try and go through that checklist is just really draining, right? It's better to spend your attention and focus on things like architecture and the algorithms involved and data structures and sort of these higher level concerns that really require human input. So I think it's that long list that it's one source of value.
You covered it pretty well. I feel like what constitutes corner case is actually really domain specific. We have one customer, for example, who has this tool that is for internal processing of big data internally. And it's really interesting to see that we have all these analyses that run on their code, and some of them provide type errors like pyr on Python. Really useful stuff that says this isn't going to function the way you think it's going to function if there's a bug. Then there's other security tools that we run on their code base. It's like, oh, well, you're executing this improperly, or you're reading this from an unsafe source, and they don't care because in this context, it is a tool that they run on internal data. So really, what constitutes a corner case is hard, and this feeds really well into the distinction of the static analysis of 10 years ago and static analysis of today. 10 years ago, you might run this weekly run every week, and you just know that these bottom 50 errors you ignore every single week because they're exactly in this corner case variety that your company just happens to not care about. But when we can run it on an incremental manner, we can show you only the incremental bugs. And so unless you've actually introduced one, you never see it again. So it has this filtering effect that any false positives just don't arise anymore. And that's really helpful when you get into tools that detect corner cases.
Is there a way to label things that maybe are actually problems, but you haven't gotten around to fixing yet?
It depends on the language and the tool. And Muse is a platform supporting many tools. But yes, there are, especially in the Java ecosystem, a lot of ways to annotate code and to make the tool ignore issues. What I see the industry drifting toward more, though, is a way to have machines learn about the false positives that have persisted in code for a while and to stop reporting on them, and to have human mechanisms, such as the feedback on pull requests and only on changed code, so that we don't actually present the user with data that about bugs that are pre-existing, about bugs that have nothing to do with what they've written. So it's sort of a 1-2 punch of a technological solution where we filter out bugs and we talk about false positives less, and a human solution where we present the right data at the right time.
So it sounds like you all and your tools are sitting as a bit of an interface between what may have historically been research tools and actual developers and large systems. It sounds like some of the work you're doing is modifying the results that you're getting back from those tools, but are you also providing feedback into those tools to help them meet the needs of developers better?
Yeah. So we do, when we set up and configure the tools, bring a lot of our own experience, but also what we've seen from running these tools at scale over a lot of code. What people are caring about, what works, what's considered noise, what's considered valuable, and I think it impacts what you present and how, but also how you present it, right? So like you might want to report something, but not make it block the build, right? There's a lot of nuance you can have, especially when you're part of the code review process. That issue is going to be seen. Someone's going to look at that and have some workflow for triaging that and signing off ultimately on the merge request or not. And so, yeah, we've certainly learned a lot, like coming from the academic side of things and just writing tools and thinking, oh, all I need to do is produce a list of results and then that tool will be valuable. And, if I can find, the more things I can find, the better, even if it's a little bit noisier, right? Like that doesn't necessarily intersect well with the day-to-day development world, right? And so we've learned a lot, as we've brought these tools to practice about that developer and really user interface side. What do people expect to see? What makes sense and works well with
That's really cool. Is one of the things that's going on? I assume you're getting enough view into into some of your customers' workflows that you're actually seeing people interacting and communicating around some of the issues that the tool raises. Is that's actually seems like a really big benefit, is that I'm not the only one that's going to see the bug or going to see the tool response, but that maybe me and my team can see it and we can have a conversation about it right there.
Yeah, that's right. We do see discussions of the bug. We see people, commenting on how they fixed it, following those code review workflows. And yeah, it's, I think really, it's a really exciting thing. It's honestly something we want to find good ways to share with the research community, involve the research community in. It's really hard as a researcher developing a tool to, first of all, to roll it out to a lot of repositories and then, collecting feedback is yet another hurdle. You can try to reach out to people and email people or run user studies, but that's all very involved, right? And adds a lot of overhead to your research. And so, to the extent that we can make our platform available as an experimental platform, especially when it comes to open source repositories, right? And, easily running tools over open source, collecting results, and then acting on those, reporting those, and as part of the experimental results section of a research paper, like that's definitely something that we want to support. And I gave a talk at the Infer Practitioners Workshop at PLDI, and we have a tutorial coming up at SecDev as well on using the Muse platform for exactly these purposes. And so, I'd encourage any listeners who are themselves program analysis researchers to check that out and see if that would be useful in their work.
It's interesting that you're leveraging pretty cutting edge research and tools to help kind of people build better systems, essentially. But at the same time, the way this conversation started, we highlighted cultural practices at the very top, and that really resonates. When it comes to tech companies in general, unfortunately, not every culture is great. That from time to time there are places. Well, let's be honest. Often there are places that are a little bit more toxic, where maybe developers are put in the situation where they're blamed for things. I know you thought a little bit about that. I'm just curious about like what your take is on tools that kind of uncover problems, and how does Muse tackle that in terms of kind of helping the developers as well as the whole system that it's trying to find the issues with.
Yeah. I mean, I think there are a wide range of cultures and practices out there, and one thing I was excited to get to do recently is participate for the second year in a row in the State of the Software Supply Chain research with Sonatype. And so this is research we've done the last couple of years on development practices in open source. And then this year we looked in particular at development practices at enterprise companies, and did a survey of both cultural practices, but also tooling that's in use and then things like job satisfaction as well, right? And so there were a few interesting things we found, and the report's not out; it'll be coming out in the next month or so. But some of the interesting findings are that organizations like open source, we had this collection of attributes that we called open source enlightenment, right? So it was things like, do you support contributions back to open source, right? Do you upstream your changes? To what extent do you share some of your work as open source, right? If you do you accept external contributions or not? Things like that, and that was very highly correlated with job satisfaction. It was really interesting, like sort of how close to the top that was. We also found that when it comes to these practices around security and in particular compliance, right? So compliance is a big concern, especially in highly regulated industries like finance and banking, but even like retail brands, consumer brands, anytime you're handling credit card information or personal information, you have a lot of regulations you have to adhere to. And so that sort of necessarily imposes upon the software requirements in terms of the development process and the checks that you're doing. And so you could see there was sort of a group of companies that didn't have those concerns, didn't have a compliance process, didn't sort of worry about that, right? And they reported certain outcomes in terms of agility and velocity, and how quickly they release and how quickly they can turn around code changes and things like that. And then like as soon as you shift to having any sort of process, you sort of like, that's unattainable, right? Like you can't move that quickly and still pay attention to what you need to be paying attention to from the security and compliance side. But then within that subset, like once you make that decision that like, yeah, we have to comply with this, we have to have internal processes that ensure X, then tooling becomes very important, right? And things like tools to analyze dependencies, to do static analysis, to help manage your workflow. Those start to be the factor that differentiates sort of high performers within that class from lower performing companies.
That's very convenient.
That's a great external view. The internal view, you said we've thought a little bit about the sort of tension between the developers in an organization and maybe the management of those developers. That's actually not true. We've thought a lot about that tension. And so we really try hard to be the developer's best friend. We want to bring all this information and all this power to the developers while they're developing, so that these sorts of issues don't propagate into the security team's purview, the QA team's purview, or production, and then suddenly you do have this negative impact or this perceived "you're making my life hard" sort of dichotomy. And we want to kind of make the developer and the security analyst and cozied up more than adversarial. We believe that with some tooling and with an avenue for other teams to add tooling to automatically check the code before it gets out of development, we can make this a much more cooperative process to the benefit of the entire company.
So the idea is maybe to try to kind of avoid the situation that maybe a lot of developers have been in, where you kind of dread like the pen test results, basically. You don't want to dread them because really at the end of the day, you want to know, like, is my code secure? Did I do a good job? But you kind of know maybe your manager is going to be like, why do we have 5 findings? Why are 3 of them high priority, high impact? And it sounds like maybe you're suggesting part of the nature is that we're waiting until the end of the process to get that feedback. And if we can do it from day one, if you do your first day of development and you get some feedback there, it's not such a big deal because, yeah, of course I made a mistake. I've only been working on it for a day. Let's fix the mistakes. Let's move this forward, and we'll keep doing that process every time. Because I think a lot of people have been in that situation, and it's stressful. It's not just stressful for the developers; it's stressful for the managers who now have this really fancy looking report saying how insecure their software is.
Yeah, I think the best teachers make sure that you're set up at the end of the semester to pass the test if you've been doing all the work and paying attention, right? And I think the best security teams set developers up to to pass whatever that ultimate gating process is. And I think, yeah, running these tools as a continuous part of development can be a big factor in making sure that you pass that test. We talk a lot about continuous assurance, which is this idea that as you're trying to raise the quality of your software, as you're trying to attend to various compliance requirements, you try and do that in a more and more automated way. The same way that continuous integration and continuous deployment, right, have automated those build, test, and deploy processes, right? We see more and more people in industry, large companies out there making changes to automate their compliance workflows and their security workflows. And so, one thing that we've tried to do with Muse is really build a platform that's focused on supporting that sort of automation, that security and compliance oriented automation process. Because it's huge in terms of the difference it makes in the day-to-day life and happiness of the development team.
And this is something that both of you have been kind of building to for quite a while. I know the two of us, Stephen, worked on the Amazon stuff, which has a bit of this flavor. And then Tom, I remember what I believe was in some ways the inception of Muse. At one point you said, we've got to just do this. We have these tools at Galois. How do we integrate them into GitHub, basically? And I don't remember how long you took, but you wrote a Haskell program.
Yep. I took about 3 months, and I put together, I glued together some Galois tooling into GitHub comment system, and it works quite well. The main motivation there was that to run that particular tool, you had to understand approximately 5 languages. You have the language you wrote your code in, you have your language you wrote your specification in, you have the language that glues the two together, that has a couple of sub-languages, and it becomes a nightmare. And that's why people pay Galois to run this thing, because you get true value out of it. But can we make that more automatable? And more easy to apply, so that we can apply it to code bases that don't need to invest such high amounts to their correctness. That was definitely a huge motivation, is making all this work accessible.
That was 2 or 3 years ago?
Yeah. Yes, it was too.
How has it been to go from that, the 3-month hackathon project, more or less, to you all have just released, and you're actually, sounds like you're seeing your tools make real impact on large systems. How is that for you two?
Gratifying, in a word.
Yeah, it's been really exciting to see it come together, and you discover a lot of things between the prototype stage and feeling like you have a finished product that you didn't count on or didn't anticipate, right? But working through that, we have an amazing team at MuseDev, just a great team of developers and people supporting on the business side as well. And it's been a really fun process to put it all together.
And a really unique part of the way, not unique at Galois, I guess, but unique the world of software engineering, is that you all made the choice to develop this in largely Haskell, right? Has that been a good choice for you? Are you enjoying that? Is it productive?
It is very productive. It's been a great choice. The language expressivity is tremendous, and the ability to mock and model aspects of the real world and simulate things so that we can run the whole system in isolation is hugely beneficial. That is a whole conversation of itself. At the same time, it's not without costs. You work in a small ecosystem, and it is bushwhacking everywhere you go. If you want to connect to this not entirely rare but not mainstream database, okay, make a database library. You make that driver. Now you own it.
And a lot of what I'm hearing from both of you is that in some sense it doesn't matter, because you care far more about the team than the tooling, and that I would guess that you would make a bet on your team regardless of the language that you all are programming in.
Without a doubt.
How have you put that team together? That's not an easy thing to get to that point, and you've done it in a pretty quick turnaround.
We tried to pull a bit on social networks, and our first few hires came from social networks. Just some great people we knew through the grapevine that you didn't really interview them so much as they interviewed you, because they came with such high recommendations. So that was a nice start. And then it was, tech interviewing is a long, painful process, because there are just so many great people out there, and you just need to figure out which one is the best fit, and who would be quite pleased to be there versus who is looking for just their next thing, which is legit. But a lot of hard work is the summary.
And then the hard work doesn't stop once you've got the team. You've also clearly put more thought into how you allow that group to be productive. Is that's you think about it externally, and as you mentioned, internally. What's the culture like at Muse?
Well, there's a lot of individual responsibility. We have a team that tends to accept some assignments that are customer driven, that say, hey, we need this and that, and then they'll come back at you, not only having finished that in some sprint, but also said, oh, by the way, I noticed we need a dashboard, or we didn't have these tables tracking this information in the database, so I just made that too, and here it is at the review time. So it's amazing to me that when you give good people freedom to kind of just understand the space and see the needs better than you can, because they're the ones building it. They will come back with things built that you didn't know you needed, and that has been a great thing to experience.
Sounds familiar. Sounds like you've taken a trick or two from the parent company, from the mothership.
Yeah, I was going to respond with a quote from the mothership of the word for a job well done is more hard work. That's exactly what Joey was just saying.
And what's the background of the team that you've been hiring? Because you're in this interface position where you need to understand what's coming out of these tools. You need to understand how to drive these tools, some of which are pretty deep research tools, and you need to condense that down to developers. So it's a really challenging position. Have you been able to train people to understand what's going on with these tools? Have you been hiring people that already know about them? How's that worked for you?
The team is just tremendously diverse. I feel like I'm talking a lot here, Stephen. If you want to jump in, feel free. But we have a ML expert, we have a mathematician, we have someone who is just really loving dependent types and came to us by reference to the instructor. And then we have someone who is just day to day has been gluing Terraform together and keeping everything afloat in a prior company. And it's so there's no one who you look at and say is exactly like this other person in the company. They all brought a very different set to the table, a set of skills to the table. And that has been one of the biggest benefits, I think, to having this team that as it stands.
Yeah, I think if there's a common thread connecting everyone, it's continual interest in learning and in growing and ambition. Sort of self-driven, curious sort of quality that I think underlies a lot of good developers. And I think that a great example of that is we have this internal tech talk series that the development team put together. They were like, we want a time when we can discuss interesting things, not necessarily work related, right, that we've been looking into at our own time, right? And so we've heard about Kalman filters, we've heard about data analysis and machine learning with Python, just a wide variety of different things that people have shared that they're just personally interested in.
And presumably you're all absolutely thrilled to have released. What does release mean for the world? What does it mean for me as an external person to Muse?
Yeah, so it means you can go on GitHub. You can sign up. Before this, we were in a closed beta period, so you get, we sent out some invite links. We had some people using the system as we developed it, so we could get that early feedback. But there wasn't a way for just anyone to go out and sign up to use the service, and now that exists, right? Anyone can go to GitHub Marketplace. They can install it. It's free for public repos and free for open source repos. And during this early access period that we're in right now, free for private repos as well. So like everyone, whatever sort of software development you're using GitHub for, right? Whether it's at your company or personal projects, you can go and try it out. We're continuing in a private beta phase we have an on-prem product. So one thing about large enterprises and how they approach software development is it's still mainly an on-premises development process, right? So there's infrastructure that the company manages that's either physical infrastructure in their data center or virtual infrastructure in their AWS instance, right? But they're managing their version of GitHub Enterprise. They're managing a Jenkins instance. They're managing, sort of whatever is involved in touching their code exists within their firewall, right? And so you have to support to reach those customers and bring the value of Muse there. We have to support an on-premises product as well, and so we do provide that. We have some beta customers that are using that. That's continuing in beta, and certainly if people are interested in trying it out, reach out. But yeah, I think the cloud SaaS version is what's out there, and we're really excited about it because that really is the easiest way to try things out, right? It's just it's the onboarding process is very smooth.
And if I'm kind of listening to this and wondering if Muse is for me, how would I know?
Yeah, try sign up. Try so if you go to the marketplace and install it, it'll sort of walk you through the few steps to pick a repo to run it on. It'll try and auto configure and run a variety of analysis tools on that repo and give you results. And so go through that process, see what the results are, see if it looks interesting, and then think. We've been talking a lot. Like it's interesting. People, when they first try it out, everyone starts with give me that bug list, right? Analyze my repo and do show me the 1,000 bugs that I'll probably never look at again, right? But that's your first window into what sorts of things this tool can find, right? And so I'd say, look through that window, take a look at the results that it provides, but then think about using it day to day as part of your development process, because that's really the typical mode of interaction is you're just developing code, you're just submitting PRs, and then you're seeing those results when they come up and when they're applicable, and you don't have to think about it otherwise.
And the evolution is, as Tom mentioned, this iterative process where you start seeing not all of the old issues, some of which might be false positives, but you start seeing the things that changed and the things that might be new risks as time goes. That's the evolution you're kind of hinting at?
Well, yeah, during as part of that pull request based interaction, you'll only see results that pertain to the code change that you made, right? So it's necessarily scoped to the change and to to that bit of code that you just wrote.
That makes sense. And that works for open source setups as well, where maybe I'm accepting pull requests from people I barely even know. Is that a really valuable thing for them?
Yeah, that's right. And one thing we've heard particular interest in some of the open source projects is some things you were talking about IDE support, Joey, and things you might run in the IDE. A lot of companies will have a standard where everyone uses this IDE or everyone uses this IDE plugin, and so certain sorts of bugs are expected to be caught at the IDE level. But when you're an open source project and you're getting external contributions from the community, you don't know what they've run on the code. You don't know if they've run check style with the style preferences that you told them to and everything. And you could run that as part of CI and get sort of a report at the end of the day that you can go and access in Travis or whatever. But you can also just plug that tool into Muse and then see those results during code review, only in the cases where they're applicable, right? So it gives you a way to centralize your scanning infrastructure, even when it's a community project.
So if people have been running those in the IDE, they'll never have to deal with them as part of the pull request. But if somebody hasn't been, it still lets you maintain the standards that you expect of your project, more or less.
That's right.
That's right.
Yeah.
For people who might be in the position of, for people who kind of develop research prototypes and things that might, whether assurance tools or otherwise, that might get used from developers. I'm curious to kind of hear from you what have been the things that have surprised you in the process, and what are the various things that end up being important from an adoption perspective when you're building things that are coming out of research that will be used by kind of a more general population. I'm curious if you have any thoughts on that.
Yeah. So there's a few things that come to mind. So one is just sort of what separates an actionable bug report from something that maybe makes sense to the tool author, but not a developer without that background. So you see that even in commercial tools, where like tools that are aimed at security teams will tend to present security issues differently in a more technical manner, usually than tools that are aimed at developers. And I think so that's important. I think also just providing the right sort of feedback. So I mentioned, whether you break the build or whether you don't, what is actually a sort of universally something that people want to know about, right? Versus something that's maybe more stylistic. And then the other thing that comes to mind is configurability, right? So often different projects will want to deploy tools in different ways, and so there's this balance, right? Not everyone wants to take the time to configure something, and so you want to provide sort of value out of the box and have things have things tuned appropriately to begin with, but it is nice to provide those levers, those things that you can go in to tweak. And so one example of that is we've been doing work to support information flow analysis and finding cross-site scripting and cross-site request forgery type things. Data that's not properly encrypted before written to disk. Those sorts of information flow based errors is a place where configuration is really important, right? Because the sources of user data in one application are going to be very different from the sources of user data in another application, and you need a good way to specify that.
So what I'm hearing is some of these analyses that you're able to run through Muse are going to more or less work out of the box, and you're going to get some nice feedback right away. But others you're going to need to give a little bit to get better information back.
Yeah, I mean, we work hard to make sure that it delivers what we consider valuable results and what we think developers in general will find valuable, sort of as it's configured when you first turn it on. But you can certainly reach in and tweak, what you want to see, and we see that in particular in the stylistic space, right? Do you have a particular coding style that you're trying to enforce? If so, then you might want to do some configuration or even add a tool, right? So we have a plugin interface where you can easily add your own analysis tools, and so people will use that sometimes if they have a particular tool that's looking for coding style issues, or maybe scanning for authentication tokens or other secrets that shouldn't be in the repo, things like that.
And if I'm a developer on the other side, if I'm making tools, like let's say I'm doing a new Python static analysis and I don't know how I'm going to make it work on thousands and thousands of Python projects, is Muse provide something for me? Would I need to reach out to you?
Yeah, definitely reach out to us because we do have an API for kicking off those analysis processes, right? So like it's basically an API for saying, run analysis on this GitHub repo and give me the results. And so then you can programmatically kick off those experiments, collect all those results, do your data processing and so forth. It's a really great way to run those experiments at scale. And also, let us know if you have a really awesome new Python analysis, because like we're always looking for new tools in that space and in other languages as well.
And then I guess on the other side, if I'm using all of the Python analyses in Muse and you all discover a great new one, what happens exactly? Do I get that right away?
Yeah, that's the beauty of like software as a service, right? Is it's just always up to date, and not just new tools, but as new versions of the existing tools that we support come out, you get those new versions, and then if they add features, configurations for those features that are tuned to be low noise and high value, all of that. If you like, all the tools we incorporate right now are open source, so you could go get them and integrate them in yourself and sort of build the infrastructure we have, try to replicate that. But like there really is a lot of work that goes into not just building those integrations to begin with, but then supporting it over time, right? If you think about the number of new releases of tools and rule packs and configurations, and over time, and then keeping that up to date as language systems evolve, as new versions of Java come out, changes in the Maven build system or Gradle if you're using that, there's really a lot of support and maintenance that goes into that process.
Can you give me a sense of how, like you say I have a Java project, how many analyses and tools am I likely to have running on my code base?
Yeah. So right now we have 3 tools that we run by default over Java code. There's the Infer tool from Facebook. There's ErrorProne, which is a tool out of Google's developer productivity group. And then there's FindSecBugs, which is a community-supported project that's really focused on security, like API misuse errors, crypto problem, insecure crypto use of that, things like that. And then we also support PMD as an optional tool. Some teams are using that. And one thing that's cool about a tool like that, so PMD has a number of rules that span the range from like, oh, this is definitely an error, to like, this is stylistic and maybe it doesn't apply to this code base, or maybe it does, right? And so you might have a PMD configuration that you're running in CI already that's catching certain types of things. But there's other things that are, sometimes it's a bug, sometimes it's not, but it's not reliably enough, it's not often enough a bug that you want to break the build on it, right? But that sort of rule you can still trigger via Muse because it'll just show up as a pull request comment. You can deal with it during, as part of your pull request workflow and decide in that instance, is this something I care about or not, right? You don't have to break the build. You can triage it as part of that code review process.
I see. So some of what you're saying is some of these tools that are more configurable, and that if you want to always get the perfect results, you're going to spend a lot of time twiddling the dials on and trying to get them just right. In some sense, you don't have to worry about quite as much with Muse because you're only going to get a few results with every small change, and that it's much easier to filter those as they come.
Yeah, I think you can be a bit more permissive in terms of how you set up your rule set. You can turn the dial a bit more towards, tell me things I might care about instead of having to set it to only tell me things that I know I'll care about.
And presumably you're doing something somewhat smart here. So if I put a bigger comment at the top, I'm not going to see all of the old issues because the line numbers change or something like that.
Not at all.
Yeah.
How smart are you being?
Naming bugs is a PhD hard problem.
Unquestionably.
Yeah. So
the heuristics work very well.
As good as we can do without writing another dissertation.
Mm-hmm. It's a PhD hard problem that hasn't been solved yet. So at least one PhD hard problem, it sounds like.
Well, speaking of, kind of PhD research type work, I know both of you before doing this were pretty much focused on really cutting edge computer science research, working on prototypes, proving things out, right? What has that transition been like to now working on a production cloud deployed system for you?
It's it's been a lot more all-encompassing. Prototypes, everyone knows, are simpler than something going out to a production SaaS system with large numbers of customers. But the breadth of concerns is truly immense. It's hard to overstate and hard to overestimate when you come from a research prototype environment. And it's not that I'm surprised at the amount of work there is, but it is something worth stepping back at and kind of nodding your head, saying yes, there's a lot here. The experience has been one where every time I thought that we had a team of sufficient size, I found that requirements grow, and we could easily justify a team of much larger size. It's interesting that how much automation is absolutely necessary to stay afloat. Every little thing really needs to be automated, even if it seems like it's simple. It takes 5 minutes. We do it every couple of weeks. No, automate that. No, don't you dare! Don't you dare! You got to take advantage of every minute you got.
Yeah, I think for me too, it's been interesting learning sort of how you have to think about things when your tools are going to be used by a bunch of people who aren't doing a PhD in program analysis, right? So when you're writing a research prototype, you can assume, well, probably you can count on one hand the number of people who are going to actually get it working and replicate results and build on it. But that's not completely true. There's some very successful research systems. But the other thing is, you can assume a certain amount of expertise from the people using it and willingness to dive deep and read the research paper that underlies the tool and understand how it works. So when it breaks and gives you this obscure error message, you sort of have a mental model for how it broke. You definitely don't have that luxury here, and you even the notion of so workarounds are not a thing, right? It's not enough to say, oh, you can get this working in this roundabout way, right? Even when you do have an actual solution for everything, communicating that solution is really hard, right? Describing how to set things up, structuring the documentation, structuring the workflow so that it's clear to people who are using the tool how to use it and how to set it up and what to do next is really tricky.
Have you started tackling that?
Yeah, so we have started tackling that. You have to tackle that, and we just learn more and more about that as we go. You see how people use the system, you see where they get stuck, and you think about ways that you can make it more clear, what the fix for that is, what the approach to solving that problem is. You try. We try to automate as much as possible in terms of the setup, but you can't handle everything. We have to understand the build process pretty deeply to do the sorts of analysis that tools like Infer do. They have to know all the source code that goes into the compilation process and run over that, have that all available. And so, there's always quirks, right? Non-standard build target, dependencies that are required. Oh, you need the source for this dependency in the directory called this, or it won't build. So things like that require setup and configuration, and so making it clear how to do that setup and configuration is something we've been spending a lot of time on.
Is this a somewhat interactive process, or does the tool pretty much always just figure out what is needed for the repository and take care of it?
I'd say over half the time we're successfully taking care of it. But there is a very long tail. We support 8 or 10 different types of ways to go out building a project across several languages. And then there's going to be another 30 or 40 that that are rather unpopular, but they still are out there. So the documentation is quite critical. You're going to reach a lot of people with automation, but you can't skimp on the ladder, because you can reach all the people with documentation.
This podcast is about building better systems, and we have people who watch and listen from kind of people who are kind of more into research and developing new approaches, and then folks who are also maybe not in that world, interested in just having their workflows be better and building better systems in general, whether it's software or hardware. Have we missed anything that you're kind of dying to share with that audience from all the lessons you've learned building this company from the ground up?
There's more tooling out there than you know. There really is, and it's probably applicable to you. The dynamic languages community have woken up to the idea of static guarantees over the decade. We've seen Flow, we've seen TypeScript and Sorbet and Pyre, the Python type checker. That world has really seen huge advances, but so too has other more niche tools. The Haskell community has, in the last months, seen a static analysis tool crop up. Go is statically checked, but it still has an additional static error analysis on top of it. Same with Java with Infer, among others, coming through. There is so much that you can bring to the table and invest relatively minimal time in. Get it working in your workflow, benefit your entire team, save you days of debugging every year.
And one of the keys to what you all are doing is making that actually be relatively little time, because I'm sure we've all gone on the tooling binge days where you just sit down and you're like, I'm going to get everything working. I'm going to get all these checks running. And in your own environment, it takes you, like, you're at the end of the day and you're like, all right, I finally got a red squiggly line under my Haskell type that wasn't type checking.
Yeah, we've definitely worked hard to make it easy, but I'm really interested in the world moving forward, and the world becoming, computer science becoming not a Stone Age sort of early days development. I want to see this field progress, and however you get the tools into your platform, into your process, I encourage you to do it. Reach out and talk to us.
So it sounds like you really feel like we've been behind for a long time, and that this has been a long time coming, which I guess again is what drove you to say it's time to do a 3-month demo and actually show some people what we can do.
Oh yeah, I could give a very long spiel about how I feel like computer science has not progressed very quickly, supporting itself and maturing as a profession, as a field, but it's getting there.
Yeah, I think there's been some really great progress there when it comes to, especially on the program analysis side, when it comes to sort of the collision between the program analysis communities and the industry development communities, right? There are a whole lot of things that happened on the industry side, DevOps and Agile and new ways of building systems, microservice architectures, so there's been a lot of progress in how software is built that I think it took a little bit of time for the program analysis community to catch up on and get plugged into. But it happened, and I think it's interesting. It happened largely by virtue of researchers moving into industry and back, and sort of that back and forth involving like exchanging personnel. Like that's great for exchanging ideas and really changing people's point of view. And so I think we've seen a lot of progress there. There's still a lot of opportunity there. to make tools even better suited for industry development and even more focused on the sorts of concerns that pop up in modern development environments.
And I don't mean this question, I guess, in a Muse specific way, but I'm nodding my head when Tom's saying we're in the Stone Age, we need to move things forward. What would you recommend doing? How did you both take the step to start actually going from one research project to the next to making impact on a wide range of systems? What did you both do?
I really just started to use the tools. I started to use SAW and prove things with SAW. So if I wrote an answer to someone's question on the internet, because I really enjoy the whole mentoring aspect, the connection and the educational aspect that the internet provides. So if I developed something for that, then I would try and prove something about what I built with SAW to teach myself something. And then I iterated from that, and people came to me and said, "Well, try these other analyzers." Someone I think might have been Mike Dodds came to me and said, "Hey, we try this Infer tool." And so, okay, I tried Infer, and while I was working on a crypto research project, I also was working on making Infer work in the same environment I had SAW working in with GitHub, and I had this deadlock issue with Infer. And it took me an embarrassing long time to realize, I could actually, I'm sorry, I had deadlock issue with the crypto project. It took me an embarrassing long time to realize, I could actually, take this thing I'm doing with the other 20% of my time and apply it to the thing I'm doing in my day job and solve the problem. And it did solve the problem. It found my bug in my day job. My side research project did it. And that's when I said, wow, it took me that long. I wonder how much evangelism is it going to take to get the rest of the community on board.
Yeah, I think another thing that's really can be really valuable is just, especially if you're still a student doing research, internships in industry, to get a sense for, how software is actually built. And like, I think, that obviously is a big time commitment and requires the right opportunity. But more and more there are conferences and workshops that have significant industry involvement. So like Facebook has a great workshop called the Testing and Verification Symposium that they host every year, that brings together industry and research, academia, and so forth, so that people can learn from each other. But other large conferences, PLDI, POPL, there's a lot of industry participation in these now. So I'd say seek out people who are there embedded at the Amazons and Facebooks and Googles and Apple, and learn from them, ask them. Tell them about the research that you're doing and ask them if that would be useful in their workflows, or if they can think of some variation on that would make it more useful.
Yeah, that's great. I think Tom's answer struck me in that I suspect anybody who's done a certain class of tool development, which I've participated in, has run into this situation where they spend, we'll say, years in their PhD building a tool, and at the end they run it on a 100-line program and they're like, look, it worked. And then it's like, well, my PhD is done and I'm going to go on to the next thing. I don't know how to support that sort of thing in academia. That's I think an open question.
Yeah. I think the incentives have to change somehow. Like what's considered publishable and novel, it would have to shift a bit to be more supportive of new applications of existing tools. And you see conferences accepting case study reports and so forth, but they're sort of like, I think that's still not viewed on equal footing, and not as interesting as a new analysis technique, right? And so I think finding a way to reward sort of continued development and use, like you were saying, it's like you need more than one user, you need more than one set of examples you're applying things to. It's really the systems that have the biggest impact are the ones that are applied over a number of years and sort of built on by multiple people. And so those can be hard to support. I don't have a good answer, but we need to find more ways to encourage those projects.
Yeah, I really like this. I don't remember the exact paper, but it was a paper by the Infer group, and I remember it was even anecdotal stuff, but it made such a big impact on me. And I'm sure you have read this many times over, but they sort of broke down, well, we were looking at bug reports from Facebook, and if we gave them overnight, then nobody fixed anything. Like literally 0 bug fixes resulted. And we brought it down to a few hours, and then And then we started to see a little bit more, and we got it within 5 minutes. And then all of a sudden everybody was fixing everything. And so reading some of that stuff is so incredibly valuable and impactful, even when it's anecdotal in that case. I would love to see more of that. And I sometimes just don't feel like I don't know where to look.
Yeah. I love that story because it's like the same analysis just running in a different way, right? And you have this difference between, they, almost a 0% fix rate when you're applying it overnight and 70%, when it's in code review. And yeah, I think those lessons are great. The paper that comes to mind there, maybe it's the one you're referring to, is there's a paper on continuous reasoning that Peter O'Hearn published in the last couple of years. And there he describes that principle as, he coins the term the ROFL principle, for report only failure list, right? Like as a tool author, all I have to do is report a list of failures, and then my job is done, and people will love it, and the world will change. And then what they discovered when they tried to apply it at Facebook. And yeah, I think there's a lot more stories out there about that. And and it's good to see industry sharing these. Google has a couple of really great communications of the ACM articles about their use of static analysis internally. But I guess that's another thing researchers can do is familiarize themselves with these reports from industry that we do have.
And I guess efforts like Muse in some way they're a chance for everybody to win a bit, because it sounds like you all are doing a lot of this work to bridge the gap between, well, I'm making a tool, but like as an academic researcher, I don't have the months that it would take to integrate with 20 build systems, for example. But that's not work that you should have to do one per research project, right? This is work that you should maybe have to do once or twice, well, thousands of times over, but you can do it once or twice for each individual build system. And if you're consistent about the way that the API you mentioned, you had a programmatic interface. If you're consistent about that, then hopefully some other people can not have to do that work, but still actually get a chance to get their tool running on a lot of different code.
That's right. Yeah. What we're finding so far is that the sorts of integrations that you need to support applications in industry and integration with GitHub and things like that can be done in a way that's separate from the tools themselves, right? And so you can solve that problem once and for all for all the various tool authors. And like you said, no one should have to do that. Certainly not as part of your PhD research. That doesn't need to be between you and graduating.
And of course, when you say solve the problem once and for all, you mean start a company that's going to work for as long as you all can possibly work to keep supporting everything as it changes, right?
It's a process, not an event. Yeah.
So for people on both sides, researchers as well as developers that want to kind of leverage Muse, what should they know?
So on the developer side, I would say, go try the tool, connect on GitHub Marketplace and install it there, check it out. And make use of the feedback feature. There's a form in there that you can fill out to tell us how it's working for you. We want to make this tool the best way to try out static analysis tools, especially cutting edge results that are coming from the research community. And so let us know how that's working so that we know what changes we might need to make there. On the research side, if you're someone producing one of these tools, developing it, trying to experiment and see how useful it is, how generalizable it is, what the false positive rates are, and so forth, reach out to us about using the Muse API to run large-scale experiments and collect that data, because we really want to support that research and experimentation process.
Fantastic. Well, that's the end of our questions, I think. Thank you so much for joining us today and spending this time with us. It was a pleasure chatting with you.
Yeah, thank you so much. Thank you. It was great to be here.
Absolutely. Well, this has been another episode of the Building Better Systems podcast. Thank you very much for watching and listening, and we'll see you next time.